Hi! In this lesson, you're going to look at 3.3 properties of linear relations. Using example 1, Homer purchased a new car for $25,000. Marge purchased a new car for $22,500. The following graph shows the values of the cars over a number of years. So here's a graph, shows two lines. You are asked to label Homer or for H and Marge for M beside the lines representing each. So here, the blue line that starts a little higher should be used for Homer's car because his new car has a higher purchase price or starting price or initial value than Marge's car. State the y-intercept of each line. Interpret the meaning. So yesterday you learned that the y-intercept of a line means where the line crosses the y-axis or the dependent axis. So Homer's car, his line touches $25,000, and for Marge, her line touches the y-axis at $22,500. So these two values will be the y-intercept. And the meaning of these two numbers in this situation would be the initial values or the starting value of each car. Part C. Which car has a more rapid rate of change? Rate of change means how quickly the price of their cars is changing. So from this graph here, you can see that after 1 year, the value of Homer's car decreased by about 1 to 3 units. And if you start from Marge's initial value, after 1 year, her car only decreased by about 1.5 unit on the grid. So it tells me that Homer's car's value is actually dropping faster. If you compare the steepness of the two lines, Homer's car's line is dropping much faster or has a steeper slope. Therefore, we can conclude that Homer's car has a greater rate of change. And to relate the steepness of the line to the rate of change, it is obvious from this example that the steeper the line, the greater it is the rate of change. And the steepness of the line is called a slope. And the definition of a slope is rise over run. Rise meaning how many units it goes up and down, and run means how many units it goes sideways. So if I need to calculate the rate of change of the value of Homer's car in part E, what I can do is on the graph, I can pick any 2 points on Homer's line. So I have picked the first point, which is the y-intercept, and also the point in year 4, so that I can show a bigger rate triangle. You see this light blue here? I have reproduced this light blue triangle here in the question. And according to the scale on the axes, we are going down from $25,000 to $13,000. So the rise here is actually a negative of $12,000. And the run is going from year 0 to year 4, therefore 4 units, just like this. So combining this information to the definition of slope, which is rise over run, I can say that the rate of change of this car is negative 12,000 divided by 4, or negative 3,000. And if we apply the units of the variables that we're relating in this question, we can conclude that the value of Homer's car decreases by $3,000 every year. Question F. Determine the x-intercept of line H. What does that mean? Well, yesterday we saw that we can actually come up with the equation of a linear relation by looking at a starting value or fixed value or base value, and then adjust that using the constant changes. So here we start at 25,000 as the y-intercept. And then every year, the car decreases its value by $3,000. So putting this together, we have y equals 25,000 minus 3,000 times x. And if I'm looking for the x-intercept, I can sub in 0 into the y value and solve this equation. And it tells me that the relation tells me that when x is equal to 8 1/3, the y value on this line will be 0. Interpreting this meaning, it means that Homer's car will reach $0 after 8 1/3 years. Example 2. The value of an antique violin is y equals to 300x plus 32,000, where y is the value in dollars and x is the number of years from now. So in part A, if I'm looking for the current value of the violin, I need to know what year we're talking about. Well, when we are starting out, currently, initially, we can say that the x value or time is 0. So substitute 0 into the equation, work it out, and you get 32,000, which means that the current value of the violin is $32,000, and this is a partial variation. B. Find the value of the violin 4 years from now. So similar to part A, that means you set x equals to 4 and solve for y. When you do that, you'll find that the violin's value will be $32,200 in 4 years. At what rate is the violin's value changing from year to year? In the equation, notice that the value that keeps changing, or the rate of change of this linear relation, is the coefficient of x, which is 300. So this is suggesting that, well, starting from $32,000 in year 0, every year the violin's value increases by $300. Therefore, we can say that the rate is $300 per year, or simply 300. Example 3. You're given two tables of values, and we want to figure out which relation shown in these table of values has a steeper slope. One way to figure out which line has a steeper slope is, of course, to graph the ordered pairs as seen on the graph. But sometimes you can also try to find out which linear relation has a steeper slope or a greater rate of change just by comparing their first differences. What is first difference? Well, first difference basically asks you to list all the x values in order and then write down the associated y values, and then you compare the change in your y value as you go down the list. Therefore, when I go from 5 to 3, my change is -2. You can also calculate this by subtracting 5 from 3. So you can continue to calculate these first differences as you go down the list. So the next entry will be 1 minus 3, -2. -1 minus 1, also -2. -3 minus -1, which is also -2. In the second table of values, once again, the first difference is calculated by taking the current entry, -2, and subtract the previous entry, -6. So simplify that, you get 4. As you go down the list, you notice that all of these subsequent rows, they all have the same first difference. And this is a characteristic of any linear relation. You always go up or go down by the same value. And of course, the line that has a steeper slope should have a bigger number as their first difference, whether the number is positive or negative. More formally, you can also calculate the slope of a line once you know any 2 points on the line. We say that a line segment AB has endpoints A with coordinates x subscript 1, comma y subscript 1, and B, which has ordered pair x subscript 2 and y subscript 2, using this formula. The change in y is y2 minus y1 is the difference, and the change in x is the difference between the x coordinates, so x2 minus x1. We're going to practice using this formula to calculate the slope of the following line segments. So when you're starting out, if you're not too familiar with the notations x1, y1, x2, y2, I would suggest that you write them above each number in the ordered pairs. And so to calculate the slope of line segment AB, you take y2, which is 9, subtract y1, which is 3, and divide it by x2, 4, minus x1, which is negative 5. So 9 minus 3, you get 6. 4 minus negative 5, you get 9. Reduce or simplify this fraction into 2 over 3, and this is the slope of the line segment AB. For line segment PQ, you can do the same thing. y2 is negative 1. Subtract y1, 4, over x2, negative 2, minus x1, which is 0. Simplify, and you get m equals to 5 over 2. So this means you have a line that goes up. For every 5 steps it goes up, it goes to the right 2 steps. Let's put everything together in example 4. So you have learned that linear relations have the equation that looks like y equals m, which is the slope, times x, plus b, which is the y-intercept. So if I want the equation of a direct variation with slope 2 over 3, a direct variation has y-intercept equals to 0. Therefore, the equation will directly be y equals to 2 over 3x. A line that has a slope of 3 that passes through the point 5 and negative 4, I know right away that y equals 3x plus b will be the form of this equation. But I still need to know what y-intercept is on this line. So you'll substitute the 0.5 and negative 4 as x and y values in this equation to solve for b. When you do that, you get b equals to negative 19. So putting everything together, you get the equation y equals 3x minus 19. And then your last question only gives you 2 points, but you know that if I know 2 points on the line, I can use the slope formula, y2 minus y1 over x2 minus x1 to calculate the slope as negative 1 over 4. Once I know the slope, I can sub in one of the points. It doesn't matter which one. So I chose a and 0 because it's easier to work with. Sub this into your equation, y equals negative 1 over 4x plus b, and you arrive at b equals to positive 2. Therefore, the equation of your line is y equals negative 1 over 4x plus 2. So this is the end of lesson 3.3. You can always rewatch the video if you miss any part of the notes. And now you can continue with doing your homework.